Hi all. Today we are going to see about the difference between training and serving GPU missions. This is a continuation video from the last where I mentioned about the testing newly trained models on production data. I have given the video link on the description if you want to see, just go through it. When it comes to difference between training and serving GPU missions, right? First of all, say what is training and serving. Training means training a new ML model or DL model or any Gen AI models, right? That is training the model from scratch or fine tuning it. Serving means once your model is trained and you need to just give an API access to people where they can access the model. That is comes under the serving part. Okay. When it comes to training the model, then we are requiring about high computational power. NVIDIA GPUs like A100, V100, H100, H200 models. These models are highly capable models, which is used for training purposes, where these GPUs can be combined in n number of scales, like 4, 8, even more. Now Elon Musk has the highest NVIDIA GPUs in a single workstation, which has 1 lakh GPUs. As much as the GPUs increases, the power of the overall GPU also increases. So this is the first criteria. Then the large memory bandwidth. A single GPU comes with 80 GB or more, but still, if we need to start with at least 32 GB per GPU, I'm saying, then it can scale up to n number as we scale up GPUs also. Because if we need to train models, right, we need to first load the random weights, then we need to do batching on the data. So these all requires a number of memory around the model. Next is faster interconnects. When we are trying to do massive training, right, then we need lot of GPUs to if we are training a very large model, a single GPU cannot hold all the weights. So we need to distribute the weights to the n number of GPUs. So once first batch is training the first batch of weights, right, in a single GPU, then the second batch will be training the second batch weights, which is in the some other GPU. So interconnects between these all the models, right, end of the day we are going to get only one model, but interconnect between all these GPUs are very important. So we need this much fast interconnect, like NVLink or NVSwitch. Next is high storage throughputs. We need NVMe SSDs to store, to load the data, store the results from the model, to store the weights, everything. So we need as much as fast SSDs are needed. Next comes with the cooling and power. Power consumption is a massive in when we are using GPUs, and when the model weights loader and unloader, the power consumption will be suddenly rising and suddenly decreasing. These all we should need to consider. And when it comes to cooling, that is also very important, because we are trying to use multiple GPUs at a time. Cooling is also very needed. Water cooling is also will be very good in this use cases. Next, softwares and tools is like how we train the model. PyTorch is number one over here. Day to day we use PyTorch a lot in building up models. TensorFlow, JAX from Google. These are also very good tools to use. When it comes to serving GPUs, right, then the important part over here is efficiency over raw power. Actually, we don't need that number of powerful H100, A100 GPUs. We can just use T4, A10, L4. These are all serving GPUs. These have good amount of memory to serve people, not to train models. It doesn't have that much in large number of cores in it, but it too has it's a very good performing model when we compare to a consumer grade GPUs. But still, these are all very good to start with. I feel on the when it comes to serving. Next, the memory utilization. Here, once the model is ready, right, the model size will be like nowadays Gen AI models are like 200 GB or 350 GB or a minimum of 100 GB. When we are doing quantization, that comes to around 7, 6, 10, 15, 20 GB. I'm not speaking about that. I'm speaking about this real unquantized model, which comes around 100 to 300 GB. We need that much amount of memory to be present in the GPUs once that memory is available, it will be very easy for the models to serve, and it will be easy for the scaling up also. Next comes the networking part. Here we don't need that much highly efficient networking or interconnection between other GPUs, because each and every model will be responsible for separate serving on that. When next comes the storage part, the model size requires a small amount of storage. End of the day, we need to store the model in the storage, and once we need to load it in the GPUs, the data which is used to I mean, when the client hits the model, that should be stored. Everything should be there. When it comes to cooling also, it requires the normal GPU cooling. It will be not utilized up to the max level always. It depends on the user base what you have. Still cooling is very important, and power consumption will also be very important, but it will be not like a spikes which happens in training part, because the model loads the weight suddenly and unloads the weight suddenly, so there will be spikes. But here the power will be like gradually improving and gradually decreasing on the user base. The inference part of the GPUs are morely decided by the user base. When it comes to softwares and tools, right? TensorRT, ONNX, runtime, these are all optimization frameworks or optimization techniques before serving things, which will be helpful in helpful when inferencing. Next comes this also, we need to consider the uh, pruning of model, or reducing the memory footprint of the model, which we will see in the next video. How to reduce the memory footprint. As of this video, we just saw the what is the main difference between the inference GPUs and the training GPUs. Thank you. Let me see you all in the next video.